Okay, so one thing that I wanted to let you guys know is I found a few messages about this. So over the weekend, I got quite a large number of emails requesting a group, like the group was for you guys to form your 4, 5, or 6 person groups. Um, most all of them that I've seen so far look fine. I need to respond to you, but I want to make sure that so I don't respond to you until I have it recorded in my spreadsheet of who's in what group, right? So again, if you emailed me back a week ago, if you emailed me back, Tuesday, Wednesday last week and have not heard back from me, then there may be a problem with your request back then. If you emailed me Friday, Saturday, Sunday, or today about your group and I have not gotten back to you, it may be fine, but I will let you know. Okay, so it's just I'm having to take all of the requests, make sure that I have them appropriately recorded into my spreadsheet so that I don't lose track of that. Okay, all right, so I just want to make sure you know about that. Okay, so let's go ahead and continue back on with the whole idea of the integrity constraints here. So one of the things that we can also put into place about this whole idea of the entity and referential integrity is making sure that things that we need to hold true stay true. So for example, in an entity integrity, remember a primary key is some set of attributes that uniquely identifies the row. Well, since null is not nothing, null is just we don't know what it is, we can't have a null value be part of a primary key. Because if a null value is part of a primary key, then it's possible that there is a duplicate, we just don't know it, right? And so you can't have null be part of a primary key because it has to be able to uniquely identify the row. Okay. Referential integrity. So we also talked about the whole idea of a foreign key being a value in one table that kind of points to another table to get the values from there to find out what the information there is. So the example that I gave you was if we had a table that represents the courses for this for each individual semester. So course code and year, for example. But the course code is a foreign key to the course information table that tells you what the course title is, what some course information is. That stuff doesn't change across semesters, right? But if a value exists in that course table, that course year table, then we want to make sure that it actually exists in the course information table, right? So for example, if we said CSE 205 in the course year table, but there's no CSE 205 in the course information table, then what course are we talking about, right? So referential integrity simply says that if a column in one table references a column in another table, has a foreign key to a column in another table, the value has to exist in that source table. Okay. All right. There's some other general constraints we may put into place, right? Some rules that may be put into place to make sure that things run smoothly and that the data cannot be corrupted. All right. One thing we'll talk about towards the end of can't remember when this is, in a few weeks, but we'll talk more about views and how to create them. So remember when I pulled up that table and I showed you the rows and stuff in that table, what you saw was a dynamic view of the database of the rows in that table. Right. A view is something that where we can create our own dynamic view of the data, right? And in that way, if something about the structure or something about the data may change, it doesn't necessarily have to change for the user's experience, right? So we might find that a certain table, it's gotten to a point where actually, we need to create We need to create two separate tables that represent this and split them out into two separate tables for the purpose, because what we want is the database to be more efficient, and that would help it with its efficiency. But at the same time, we don't want our user to have to experience any problems, any change in how they use our system. A view would be a good way that we could do that. We could allow them to see information in a way that's they're used to. Okay. A view is a virtual relation, meaning it doesn't hold data itself, but it accesses the underlying data at the time of request. So when someone pulls up a view and looks at the information there, they're seeing the real-time data as it really is existing. Okay. So some of the purposes of why we want to have views instead of just having them given direct access to the tables. Well, one of the reasons can be security. All right. So what we might want is for users to only have access to certain parts of the database. So for example, let's say we store passwords for our users in a database table. We might want administrators to see the passwords, but I can guarantee you we don't want normal users to see other users' passwords, do we? All right. So we can customize how someone gets to see the data from the database. So this helps with security. This helps with ease of use. Again, some data, it's not so much that it's a security problem, but they just don't really want to see it. Like it's not really all that important to them. So if you think about it, if you maybe an example might be if you're listening to music on your phone or on Spotify or whatever it is that you listen to music on, there might be some information that you want readily available, the title of the song, the artist, maybe the runtime, maybe how long the song is going to be. That might be some information you want immediately available to see, right? But there might be other information that they store with the song, stuff like what year it was released, or what genre is it, or maybe even what album did it appear on, or something like that you might not want right there immediately available, that you don't want to see it right now, but it's good to have it in case someone wants to see it, right? So a view would allow someone to be able to see information that they most want to see without having to scroll through or get through other information that they don't want to see. Okay. We'll talk later about updating views, because I've realized later this set of slides about updating views doesn't really necessarily need to be in this set of slides, because we'll talk about updating when we talk about SQL here in the next set of slides. Okay, so brief bird's eye view of database and its terminology, but where we really want to get to, okay, what's really the fun here, at least for me, is SQL. So we'll pull that up. So we're going to introduce SQL today. Okay. All right. So SQL stands for Structured Query Language, and it is a very commonly used database language to be able to view and manipulate the structures and the data within a database. Okay, so let's see. Okay, so we'll talk about all these things here. All right. Okay, so if we want to have a database language, we want to be able to have a single language that someone can use that would not only create the database itself and any structures that we would need, tables, views, relationships, right? But we would also want it to be able to manipulate the data, both add data, insert, modify data, delete data, be able to view data, to be able to obtain data for our uses, to be able to view it. And we would like the language to be able to do this with very little user effort. Like we would like them to be able to very simply get access to the things that they want to get access to. view the data, change the data, be able to do that pretty easily with the syntax of this language. And it should not require it should not require a lot of learning, okay, to be able to accomplish these tasks, okay. And when I say it doesn't require a lot of user effort or learning on the part of the user to be able to do these things, mostly I'm talking about especially for those of us who do have some programming experience before, okay. So I won't get through a lot of the history of SQL, but I will let you know, I will make it clear that here there is both a data definition language and a data manipulation language, okay. So there is both a part of SQL that we use to define and manipulate the structures of the database, to create tables and get rid of tables, to create views and get rid of views, to create other types of constraints, integrity constraints, and to be able to remove those. There's also a data manipulation language for viewing and for changing data in the database itself, okay. I won't get too much into some of the history here of this, all right, but I do want it to be known that for the most part, SQL is relatively easy to learn, right? It's not procedural. Now there is something called there is something that we'll get introduced to called PLSQL, procedural language SQL. Now, but for the most part, our SQL statements we'll talk about are non-procedural. It means it doesn't necessarily matter the order of certain things, right? It's more that you are telling when you send an SQL query to the database, you are saying, this is what I want, and you're letting the database do the job of determining how to send it back to you, okay? So for example, let's say you wanted some set of data and you wanted it in a certain order. You wanted students ordered by student number. And you said, give me all the students in the database for this course, for whatever course, order them by student number, right? The database is going to do all the work of ordering them before it sends it back to you. It's going to send the data back to you in the ordered format, okay? Whereas in, say, a Java program, you might have an array or an array list of students, and you might say, I want that ordered, I want that sorted, right? And then you'd have to do an arrays.sort or some other type of sorting method to sort it yourself, right? And so that would take time, and that would take more programming on your part to make that happen. Whereas with SQL, we can say to the database, hey, you do that work and you just send me the information I want. Okay. Now, unfortunately, SQL is English based. So for those of you who English is not your first language, which I think is all of you actually, it does consist of standard English words, but they're not hard. So for example, we gave an example in the very beginning of this class today where I created a table, and you saw that the SQL that it created had a create table statement, right? Create table, my table, or something like that, right? So create table is what creates tables, right? So that's pretty straightforward, pretty standard. Now the way that we add data to the database is we don't have an add data, but we have an insert into, and then we can insert into a certain table what values we want. And then another example, how to get information, how to get data from the database is we select which columns we want to select. We say which table from which table do we want to get that information. And where is like the conditional, that's like the if statement of an SQL statement. So it's saying, I want to get this information from this table, and I only want information where this condition is true. Okay. So this is how we do a select statement. This is how we do a retrieve information. Now, the vast majority, like almost all the slides from this set of slides are going to be select statements. Okay, because select it's going to be something like 90% of the queries that you run. It's going to be a lot because we're usually just trying to see what data is there more than we're trying to manipulate it or change it. Okay. All right. So a lot of different people can use SQL, database administrators, standard programmers. I was a client programmer. I was a user interface programmer when I was working in industry, and I wrote a lot of SQL statements, right? Because even though I was dealing with the user interface was what allowed the user to have access to the data in the database. Okay, so I had to write SQL statements to be able to show the user the information that they wanted to see. Okay, a little bit of history. I'll skim through this. One thing I do want to say is, so it is SQL stands for Structured Query Language. Okay, there's an old one called the Structured English Query Language, but SQL is Structured Query Language, right? A lot of people call it SQL, even though it's not spelled this way anymore, even though it's spelled SQL, a lot of people call it SQL, and that's fine, right? You're going to hear a lot of database administrators, a lot of programmers that will talk about SQL statements, writing things in SQL, right? You'll also hear a lot of programmers like me sometimes refer to it as SQL instead. What's the difference between SQL and SQL? There's not a difference. It's the same thing. Okay, so I haven't worked. I don't know. I don't know what a Turkish programmer would pronounce this as. Maybe those of you who've had any industry experience or talked to any programmers might know what they say in the offices around here when they're talking about writing SQL statements. Okay. But in English, we say SQL, we say SQL. Either one's acceptable. Okay. All right. Keep going. All right. Now, again, just like most other programming languages, SQL has a list of reserved words and user-defined words as part of how it runs. Okay, now reserved words are fixed. You must spell them exactly as they're required. You can't like split them. You can't put spaces between them. All right, and you can't use them for any other purposes. So you cannot name a table or an attribute of a table or a column of a table. You can't name it something that is an SQL reserved word. Okay. So I don't know if anyone here has any experience in Python. Most of you, I believe all of you have some experience in Java, since that's what we teach in the 101 and 102 courses. Right. You know in Java that you cannot use int, for example, int. You cannot use int for another purpose. You cannot have a variable named int. You cannot have a variable named public, right? And so in the same way, SQL does not allow you to have an attribute called select, right? You cannot have a table with the name create, for example. All right. Python does allow you to do that. So anybody who has Python experience, you can't do that here. All right. User-defined words. User-defined words are made up of they're like the variable names, right? They're like variable names, class names. So here it's with the attribute, it's with the table names. It is the user creates these and defines what they are. Okay, all right. And again, just like when I taught you guys in 101 and 102, about how to have good variable names, the same rules apply here in terms of how we name our tables, how we name our attributes. Is we want to make sure that we give them short but meaningful names. We don't want anything too long because then we have to type it a lot. And we don't want anything like A, B, C, because then they don't really have a lot of meaning. Okay. There is one exception we'll talk about, just like with the when we talked about you could have the variable I to be an iterator in a loop. We will also have some examples of where a single character might be an okay user-defined word. All right. Now, one thing that is going to be different from your Java experience is that SQL statements are case insensitive. So what that means is whether you capitalize, so like the select statement, for example, select with all capital letters and select with all lowercase letters is the same thing. Okay. There is some desire for more readability by using indentation and making sure that you put different things on a new line. So the select part should be on a different line than the from part, should be on a different line than the where part, and each start of the next clause should begin on a new line. There's nothing in nothing that's going to make that where it won't run, but it is better for us to be able to read it if it's more formatted in a more readable way. Okay. All right. Now, the main point of this slide is helping you understand just like we talked about coding standards, about how to name variables, how to name classes, and using camel case versus underscores and stuff like that. There is some desire for coding standards to be followed when writing SQL commands. All right. Now, what the example here is that if we use uppercase letters, this represents reserved words. Lowercase letters would represent user-defined words. So let me do this. Let me pull up this here. So I'm going to show you a couple of examples here. So there's nothing that would be wrong with not using this in terms of execution, in terms of it executing your SQL statement correctly. But it is, again, it's about us reading it and about other people reading it, other programmers who you might work with and that kind of stuff. Some of you may remember that one thing that I've said before in programming classes is that your code is going to be read a lot more than it's written, meaning that you will look at your code to try to understand it. Other people will look at your code to try to understand it a lot more than the time that you're going to spend writing it in the first place. Okay, so let me show you a couple of examples here. Let me see if that'll let me do this. There we go. All right. Let me do text. Oh, where'd you go? Okay, so if I were to say, okay, select salary from, or actually, let me say select names from student table where year equals 4. Okay, so this would be an example of, okay, what we're going to do is we're going to take a student, we're going to get the names of all students where they're a 4th year student, if we had that in our database table are from our student table. Okay. This would run. There's nothing wrong from a syntax standpoint, from an execution standpoint. There's nothing wrong with this query. Now, but it might be copy. Okay, but it might be better, easier for us to read it. Oh, the font on this is not what I wanted. Is there a way to change the font on this thing? Ugh, I don't really like the font on this, but okay, I guess it's what I'm stuck with. All right. Come on, there we go. All right. So if we look at these side by side, again, these two queries are the exact same in terms of functionality, okay, in terms of what they will do. But especially when we're looking at it on a computer screen, on a type where the normal typeface, right? This is going to be a lot more easy to read than this will be, because specifically this is highlighting that this is a reserved word, right? These are highlighted reserved words. And even what might even be better is if we did something like this. Okay, and okay, where this part over here kind of lines up, right? And the way that we would do that in a typeface that's what's it called, a true type font, right? Where we would put two spaces in front of the from, so that the F lines up under the L, the R under the E, the O under the C, the M under the T, and then that way this lines up on the end, right? And then where would be a single space would do the same thing. So the W is under the E, the H is under the L, the E is under the E, the R is under the C, the E is under the T, and now year kind of lines up with this first column as well. Right? And what that does is it makes it more understandable from a visual perspective. Okay, again, doesn't change anything about the functionality. The only thing it changes is our ability to understand what this is doing. Okay. All right. I hope that's clear. Again, if we were in a classroom, I would be able to draw this on the board and hopefully have, I probably wouldn't have better handwriting than what this is, but it'd be nice. So, all right, so back to our slides here. Okay. So as far as when we see the definition of a specific type of query in the coming slides, this notation is going to be used. A pipe is indicating a choice among alternatives, so there's the options. Curly braces will say, okay, that's a required element. Square brackets will be optional. And then the ellipses here, the triple dots, will indicate some repetition, possibly. Okay. All right. So we'll also talk about literals. So literals can be numeric values like 650. It could also be a string value. Now, here's one thing. We said that SQL statements were case insensitive, and that's true for reserved words and for user-defined words like name, for example, in the last example where I said name or year, something like that. But if something is inside of quotes representing a text literal, then that case is sensitive. So London with a capital L is different from London with a lowercase l. Okay. So that brings up a point I meant to make a second ago. So I'll go back to the whiteboard here. Because this also is the same thing in terms of functionality. So all three of these are the same functionally. They look different, but they are the same. So this is different from Java. Okay. This is different from Java. And if you have any C experience, and I think Python is also case sensitive. All right. Where select in all caps is the same as select in all lowercase. Okay. So that's something to remember, that these are all the same. Okay. But a literal, such as London, so let's say I said select, well, what if I said, okay, let me do this. Change it a little bit. I'm going to say, give me the year from the student table where name equals all right. Now this and this, these are not the same query. Okay, because now what I've done is this is a value of a string of a text that starts with a capital J and has other lowercase letters. This has all lowercase letters. So therefore these two string values are not the same. Okay. So these two let me do this. So what I'll do is I'll show you like this. So green means, okay, yes, this is equal. This is equal. Red, this is not equal. Okay. So all three of these are the same. These two are not. Okay. Make sure you remember that. Okay. All right. So let's get into the format of a select statement. Okay. You're going to need to know all this. You're going to need to know everything on this page, basically. Okay. So a select statement will begin with the select keyword. All right. We have an optional distinct or all. Okay. Distinct simply is going to tell us that we want to get only the rows that are unique. So if a select statement would result in getting multiple rows of the same content of the same value, then we only want to see it one time. Okay, I'll show you some examples of how that will happen here in our examples list here. Okay, now the most common select statement you will ever write will be select star from table name. Okay, star says I want to get all columns. Okay, I don't want to tell you which columns I specifically want. I just want to get all of them. Okay, so star is a shorthand way to say I want all columns. Sometimes we might want to only get certain columns though. And what we can do is we can say, okay, I want a certain column as some new name. So we can give it what's called a new name or an alias. So we might have a column, and let's say the column name is long, or it might even be an expression. It might be a calculation like salary times 20 or something, right? Well, what a lot of database systems will do is if we put a expression here, a calculation here, then it'll give it its own name, like column 3, or value 4, some random name that doesn't really make a lot of sense. But if we say, I want to call it a special name, we can do that here with the as keyword. All right. If the column expression is just a column, just the name of the column itself, this automatically is just going to give us the column name itself, whatever it is. Okay. Comma separated. So if we want a grouping of columns, we can just do column, whatever the first column is, comma, second column, comma, third column, and so forth. Okay. So that's the select line. Then the from line, we're saying, okay, I want to get these columns from a particular set of tables, from the table. We'll talk about why the alias, why we might use that in just a moment. Actually, probably tomorrow at this point. So from a table, comma separated. So table 1, comma, table 2, comma, table 3, and so forth. Okay. Notice that the select and the from are required. There is no optional here. You have to have a select, you have to have a from. You have to be getting a column or group of columns from some table or view. Okay. Those are required. Optional. You can give it a condition. You can say, I only want the rows that meet a certain condition, that satisfy a certain condition. Okay. That's where the where clause comes in. You'll hear me say the where clause a lot. Right? The where clause is just the part of the select statement that we're saying, I want to restrict, I want to limit which rows I get. Okay. There's also this optional group by and having. We'll talk some more about what that is later. We won't talk more in the example itself because it's more understandable from the example. And then the final part of a select statement could be an order by. Optional order by is basically sorting it. If you want to have it sorted by a certain column. Okay. One thing that we'll get into in the group by and the order by. The group by column list, these columns must appear in our column list. All right. These columns must appear. The order by does not have to. I could say I want all of the I want to get all of the students in the class. I want to get all their names, but I want to sort them by their student ID. Okay. So I don't want to see their student ID number. I want to see their names, but I might want to sort them by their student number, for example. Okay. So that's a possibility. I don't have to see something in the select statement, the select part, in order to sort it in the order by. Okay. Some other stuff here. Notice that only the select and the from are mandatory. So let's take a look at some examples and end our time in the next 10 minutes looking at some examples. Okay. Let's say I want to get all columns and all rows from a specific table. So here I can either select whatever the column names are, staff number, first name, last name, address, position, sex, date of birth, salary, branch number from staff, or I can use star, the star or asterisk or whatever you want to refer to this as an abbreviation for all columns. So if you say select star from staff, it's saying when the SQL statement gets executed, it's saying I want to get all columns from that table. So when you run this query, it does this. Okay, it'll return all the it'll return all the columns, all the rows from the table. Okay. Simple example. Like I said, this will be the most common. This will be the most common query that you write. You could also say, I don't want all columns. I only want some of the columns. So you might say, I want to give the staff number, the first name, the last name, and the salary. Okay. Notice one thing, you cannot do star minus some other column. So let's say, let's go back to this one. Notice there's 2, 3, 4, 5, 6, 7, 8, 9. There's 9 columns here. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Let's say I wanted everything except for the branch number. I can't do select star minus branch number, unfortunately. Okay. So I can't just say, give me all the columns minus 1, right, or minus 2. All right. Unfortunately, if I want to get a subset of columns, I have to list out the columns that I do want. Okay, so here we want to get these 4 columns. When we run this query, we get those 4 columns, all rows. Okay. Here we might do a distinct. So if we listed out all property numbers that have been viewed. So basically in this example for our dream home case study that the text gives us, the viewing table is telling me which properties have been viewed by someone, by a user. Okay. So if I said, give me all property numbers from viewing, I might get something that looks like this. Now notice that there's some repeat here. So let's say this is all the rows. This is a new system, and this PA14 property has been viewed twice. This PG4 has been viewed twice. This PG36 has been viewed once. You know, but what I really wanted, I didn't want to necessarily have a list of all the property numbers and how many times they were viewed, because especially once this table viewing, once it gets really large, I mean, imagine on Sahib and Den, right? If I said I want to list all of the properties on Sahib and Den that have been viewed at least once, right? And if it gave me a list like this, probably millions of rows would come back, right? And some of them would be duplicates. Ugh. To see all the properties that had been viewed, I have to scroll through, right? And that one is a duplicate. That one's a duplicate. Torana, I'm not sure I understand the question. Which is the table name? Viewing is a table in this dream home example that they've defined, that basically when a user views a property, it gets an entry in this table with what property number it was that was viewed, along with some other information such as maybe who viewed it and stuff like that. Okay. But what I'm getting at with this example is what we really want to know is we just want to know what properties have been viewed. We don't need to know all the times that they were viewed. We just want to know what property numbers have been viewed. Right? So we can use the distinct keyword to get rid of all duplicates. So now if we do distinct property number from viewing, we will only get what the distinct values are. Okay. Now, one thing I want to make sure to point out before we move on, all of these queries that we're talking about here, all of the select queries don't do anything to the data itself. Okay? It's just seeing what the data is. Think of it as we are reading from a file. We are not changing the data in the file. We are only reading the data that's in the file. Okay? So in this example, if we were to run this query again, we would still get these same 5 rows again. The distinct just makes it easier for us to see the information that we really are intending to see. Okay. All right. So another example where we can calculate information. Let's say that the salary field stores what their yearly salary is, what their yearly wage is, right? And we want to see what their staff number, their name, and what their monthly salary is. Well, we can just take their yearly salary, divide by 12, and we get what their monthly salary is, right? Now, I want you to notice something that I mentioned before. Here, this is a calculated thing, right? This is an expression. And so it gets this name over here that doesn't really mean a lot, right? Call for. What is call for? I don't know what call for is, right? Doesn't mean anything. So what would be useful is if we gave it a name, okay? So we can use that as keyword to say, this is what this represents. So now when we run that, oh, I guess they don't show it as an example in a figure. But now instead of call for, what we would see at the top here would be monthly salary. Okay. All right. So far, the examples that we've gone through have all been limiting the columns, but not the rows. So far, we've been saying, I want all rows. I may use distinct to get rid of duplicates, but right now we still are looking at all rows to get our result set. But we can use the where clause to say, you know, I only want certain rows. So I only want to have all the staff with a salary that's greater than a certain amount. Okay. So I want salary that's greater than 10,000. Okay. So if we run that, notice all the values in salary over here are all greater than 10,000. Even a staff person who had a salary of exactly 10,000 would not show up in this query. Exactly 10,000 is not greater than 10,000, so therefore it would be false, so it wouldn't show up. 10,001, on the other hand, would show up. Okay. Something else I wanted to point out here. Oh, also note that if I just said, okay, if I didn't even ask for the salary column over here in the select portion, but I had this where salary greater than a 10,000 in the where clause, that would be okay. All right. So if I had said salary greater than 10,000, but didn't look at that information in the result set, that would be okay. There's nothing wrong with that. It does not have to appear here in order to appear here. Okay. We'll talk about, again, the group by is the one place where if it appears here, it has to appear here, and we'll talk about that. But right now, know that it does not have to appear in the select in order to appear in the where clause. Okay. We'll do a couple more and then we'll call it a day. All right. So we can use the or keyword. This is just like that or operator in Java. All right. So we're going to select everything from the branch table where the city is London or the city is Glasgow. I don't know how to pronounce that city. I'm not British. Glasgow. The G city. All right. So notice that when, all right. So when we get it here, all right, the cities are all either London or Glasgow. All right. And in the same way that OR is used to do an OR operation, AND is used to do an AND operation. All right. So if we had done where city equals London and city equals Glasgow, we would have gotten no rows returned because there's no branch where the city is two different values. Okay. All right. So I introduced the select statement. We'll end our introduction of the select statement there, and we will finish off. We'll get a lot more slides going tomorrow, and we'll do some examples on that SHAMP stuff. So I'll do some examples tomorrow as well, so you guys can see kind of how that works. All right. Is there any questions on what we've talked about so far? Is there any questions about? Oh, I see. I'm sorry, Tirana. I didn't see your first comment there. Viewing is not a reserved word. Viewing would be a table name, so it would be kind of like a class name or a variable name. So viewing is a user-defined word. Okay. Good question, though. I'm sorry I didn't see the first part. All right. Does anybody else have any other questions? Yeah, so we went through a lot. We went through a lot of material today. I definitely encourage you guys to keep up with this stuff and to practice. Yeah, and we will continue on with our SQL statements and learning more. We'll get, we probably won't finish all of select tomorrow, so it'll probably extend into next week. But be prepared. I will go through some examples tomorrow. Okay, so I'll pull up my SQL page, and I'll go through some examples with you tomorrow to show you how to use some of this stuff. Okay. All right. Well, thank you guys, and I will see you tomorrow again. Oh, we will start at 8:30. We will start at 8:30 because too many of you have class conflicts. So sorry you don't get to sleep in. I was kind of looking forward to it myself, but we will. It's okay. We will go ahead and start at 8:30 tomorrow morning. So I'll see you guys bright and early. Set your alarms.